Excuse me. Excuse me. We'd like to get started. Will the folks in the back who are having a wonderful conversation either join us or take it outside?
Everybody,
Either inside and enjoy IDR or outside and enjoy the conversation. Thank you.
is this one any better?
Hi, folks. We're going to be brief. We've already lost a couple of the minutes. Please read the note well. That's it for today. Okay. Oh, this is much better. This is the status of the draft. Read it. We've done really well in dealing with working group calls. Thanks to everyone. It's now time to bury Alvaro with drafts. So I think he'll enjoy the challenge. Administrivia. I've cut everything out of the agenda to have more FaceTime. Don't wait, go on. There's a status online. Go on. You were right. I was wrong. And online, there is something that anyone who is an author, I am now asking people, based on feedback from Alvaro, to put implementation reports online. For anyone who's got a written draft, I'm using those as my test case. So I will do that for you. But before you go to the ISG, anyone who has a protocol must fill out the implementation and put it on the website. If you're doing an administrative draft, you don't get out of it, I'd like to have you do a testimonial. Basically, get a quote from Jeff I. and the IANA folks and say it's cool. I'll do it for you, Jeff. For you. Yes.
There's also a draft on an experiment they're doing where you put in the functional draft, you have like an implementation status section. I don't know.
Yes. I was trying to it's a wiki, guys. Find your friends, type it in.
No, this goes in the draft.
Yeah.
I can forward that to you.
Yes, that'd be good. But I intend to do the summary of the stuff in the draft. Stefano, I'm done. You have to stay. You want the clicker?
No.
Okay.
So I have 3 minutes, right? So thank you. Okay, BGP-LS for EPE extensions. It's now working group document. Next slide. Just a very small reminder on what it is. We want to advertise in BGP-LS the topology of the peering points. So what are the peers, what are the interfaces, what are the peering ASs, and so on. So to feed the controller with this information using BGP-LS extensions. Next slide. So what we changed, very little things. We just used different objects for the peer node SID and the peer adjacency SID. In the previous version, both had the same object in the encoding that was the adjacency SID. Now we have different code points. The format, of course, is always a SID, so the format stays the same. We just call them differently. We added some text on the way we identify interfaces through addresses or identifiers. And we really thank AC for the in-depth review and contribution to the draft. Next, which was the last, in fact, so I think I stayed in the 3-minute budget. Thank you.
G?
Good afternoon, everyone. Here is a brief update of this TLSP state distribution using BGP-LS. Okay, this brief recap. This draft provides a mechanism for the collecting of the TLSP states. It is based on the BGP-LS architecture, which provide a unified protocol for the network layer information distribution. And this mechanism is complementary to the PC-based LSP report. Since in some scenarios, some areas may not be the PCCs, so they need another mechanism to collect the LSP states. And also the BGP route reflector can help to reduce the session overhead. Okay, next slide. So here's the updates and the working group adoption. We add support for the segment routing TLSPs. This is achieved based on a new protocol ID for the segment routing. And we add an operational consideration section to be aligned with the BGP-LS base document. And also, the TLSP object list is updated to include all the relevant objects about the TLSP state. Also, we update the INET section. Next slide. Here are some comments we received on the mailing list. The first one is how to specify the switching type of a non-packet RSP. So currently our proposal is to use the generalized label request object in the RSP state TLV to carry such kind of information. And another comment is how to distinguish the object defined by RSVP and the PSAP. Our proposal on this is to maybe we could define a top-level TLV. The top-level TLVs based on the source of the TRSP information, such as one for the RSVP and another one for the PSAP. Actually, the authors are open on this such comments and the solutions, so we would like to discuss further on the solution to these comments. Then we can update the draft accordingly. Next slide. Okay, this next step is to solicit more comments and review from the working group so we can revise this draft. Questions?
Thank you.
Short update on BGP optimal route affection. Next, please. A recap of the goal. The goal is to provide optimal output routing without bothering where is the route effectors or where is the client or what is the network topology between both.
Why don't you pull the mic out and
Next, please. So there has been significant changes in version 9 and 10. There used to be multiple solutions and options in the draft. And we removed many options on refinements, and we kept a single solution, which is to have the route effectors compute its IGP location based on an arbitrary IGP location. So that location may be one location for the whole route effectors, or one location per peer group or per group of peer, or one location per client, typically the location of the client. And the choice is up to the implementation, so it's very open. All other alternative solutions have been dropped, so this includes the angular distance approximation, the signaling between the client and the route effectors of the group ID, the mandating of a per client IGP computation, and also the per client BGP policy. So all those options are removed from the draft. But as a reminder, we still need the route effectors to have all the paths prior to IGP tiebreaker. So typically we need a BGP at pass between the route effectors. So obviously we had many editorial changes on text rewrite to handle that those changes. Next one. So as a result, the draft is much simpler. It's also in line with existing implementation. And it's applicable when you want to move your route effectors. So given all those changes, you may want to reread the latest version of the draft because it has changed a lot. Any question? No?
Good. So I'm talking about the internet draft making routes over aware of data link failures at IXPs. Next, please. The typical scenario is if you have a PGP session that the data plane and the control plane are concurrent. So if the data plane breaks, the control plane is able to detect that. Next, please. That is different in an IXP environment where you have a route server. There usually you have different data plane paths. So for the PGP session and for the data plane path between two client routers, there are different paths, and if the data plane breaks, the control plane is usually not able to detect that, and so data traffic is lost, so we have a black hole. Next. We came up with a solution to fix that. First, we need client routers must have a means of verifying connectivity amongst themselves, and for that we can use BFD. which is, in our proposal at least, configured to asynchronous mode and a data rate of 1 packet per second and detection after 3 missing packets. Second, we need client routers must have a means of communicating the knowledge so gained back to the route servers, and for that we use the B2P link state. And there we model the IXP network as nodes, so for the client routers and for the route servers, and the links between the client routers if there is a connectivity between them. We need a next hop information base to store this reachability information for each peer. Next. So let's have a look how this works. Let's assume peer A sets up a P2P session with the route server, then the route server sends out a P2P update to peer A with the next hop information base updated. So it says that it sees node B, and the client router receives that, so in this case A, and starts automatically verifying the connectivity between A and B using BFD in this case. And after the connectivity is verified, it updates its own next hop information base and sends it back to the route server. So you see that here the link is available in this message. Next. If the data link breaks, the client router detects that because BFD tells it so. The client router updates its next hop information base. This time the link is not, or the link section of the next hop information base is not filled, and sends it back to the route server, and the route server uses this information during the route selection process and removes all the next hops that are declared unreachable for that peer. Next. The status of this internet draft is that we have already achieved the working group adoption, and we changed the next hop information base, the way we transport the next hop information base from the client routers to the route server and back from next hop cost to PGP link state. So we are looking for feedback from the working group and also input how to improve the current internet draft. Thanks.
Any comments? Thank you. I may or may not have Jerome here. Is Jerome here? Is Jerome Duran here? Or David? I promised them a chance to present this a second time instead of just in the interim. Going once. Okay, the next person is Stefano.
Okay, an update on the BGP Prefix-SID draft. The big change is the merge with the Hannes proposal. So now we have a single proposal. And the major change after this merge is that now in the Prefix-SID we also carry an optional TLV, which is the originator sRGB TLV. So we changed the format. In the previous version, we had just what was called the label index attribute, while now we talk about the Prefix-SID attribute, inside which we have multiple TLVs. One of those is the originator sRGB. Another TLV is the index that was already before. And we also added the support of segment running IPv6 data plane. So we have a TLV for the IPv6 case. We address two use cases, the labeled unicast prefixes, 3107, and the IPv6 prefix with multi-protocol BGP. We have multiple implementations, so I think we are ready at least for asking the adoption as working group document. Next slide. Those are the different TLVs. So the first is the label index TLV. This hasn't changed, so it's the same as the encoding that was already in the previous version. Next slide. The IPv6 SID TLV is in fact just a flag, because in segment running IPv6, the SID, the segment identifier, is the IPv6 prefix itself. So you just need a flag to tell that the router is capable of doing segment running IPv6 for that prefix. Next slide. The originator sRGB, this is what comes from Hannes' proposal. So you encode the originator sRGB in the form of ranges, and you may have multiples. So you can encode multiple sRGB ranges. Next slide. This is the same. Yeah, okay. It was just to mention that you encode the originator sRGB, and this should not change across the propagation of the update. Next. So we take always the reference of the data center. By the way, the use case, the prefix-SID addresses is documented in Spring Working Group into the MSDC draft. Next slide. So those are taken from the presentation that Kiur made last time, so nothing has changed really. So the idea is what? Is to propagate in the prefix-SID a hint for the receiver of the update on which label to allocate in order to do the segment routing MPLS data plane forwarding. And so the label index TLV now contains the index that you advertise to your neighbor, and the neighbor takes this information, if it supports segment routing, and allocates a label corresponding to this. The original proposal of the prefix-SID assumes that all the routers are configured within the same sRGB. If it is not the case, it also assumes that you can know the sRGB of each individual router, either through, by example, BGP-LS, either through the sRGB originator TLV as defined in the prefix-SID. So the update gets propagated node by node, and each node allocates, each segment routing capable node allocates the label according to the value in the label index TLV. Now, next slide. If in the middle of all this you have a non-segment routing capable node, it's still fully interoperable because the non-segment routing capable route will allocate its own label for the prefix, but still the update is propagated with the attribute, so the next segment routing capable node can continue the allocation based on the index. And this interoperability is granted because the label you have to use as an outgoing label is carried by the NLRI, the 3107 NLRI. Nothing changes there. The attributes carries just a hint for SR capable routers on which label to allocate. So by making the distinction, one is for the label outgoing label use, and this is the NLRI, and the other is what is the label I have to allocate. This is the label index TLV in the prefix-SID. By keep those things separated, you can ensure a full interoperability between SR and non-SR nodes. I think this was the last slide, so I can go back to the first slide and ask next, if the working group can consider the adoption as working group document.
Can I get a sense of who's read the draft? So quite a lot, I would say. You know, we can take a show of hands for people who think it's ready for adoption. Quite a few hands, about a similar amount. Anybody want to say they think it's not ready for adoption? I don't see any hands. We will, of course, confirm this on the list, but it looks pretty promising.
Thank you.
So hello, my name is Daniel Walton. I work for Cumulus Networks. So myself and my coworker Dinesh Dutt are the authors of this draft. So the draft basically just defines a new capability that BGP can use to inform our neighbors of our host name. So this is just the normal host name that's assigned to the speaker, and we encode this using UTF-8. This is only to be used for basically for troubleshooting and for display in either debug output or show command output. This is implementation specific, but the normal use case would be that you provide a knob to enable or disable showing the host name. So this is probably the easiest capability in history. So this is the entire thing. So there's just the length field for how long the host name is and the host name itself, and then the same for the domain name. Okay, so what's the motivation for this? So our customer base is primarily data center. And in a lot of these big data centers, they tend to do all eBGP, and there is no iBGP. So that means you're BGP peering to directly connected addresses. So the challenge with that is normally, if you're peering to route reflectors, you kind of in your head memorize which IP address is which route reflector. And it's easy, but if you're peering to directly connected interfaces everywhere, all of the addresses are different, so you can't really memorize, who is who. Outside of the data center, this may also be useful. OSPF and ISIS both already have this ability to include the host name as part of the routing protocol. Okay, so just a quick example. So this is a show IP BGP summary from a leaf node in a data center. So the first two sessions are to a spine layer, and then the bottom two sessions are to a Tor layer. The key here is if you were to go to the sister leaf node and do show IP BGP summary, that box would be peering to all of the same spines and Tors, but you would see different addresses. So it's very challenging to jump from one box to the other and remember who is who. So with the draft in place, this is basically the whole change. You do show IP BGP summary, and you just display the host name instead of the address that you're peering to. So feedback that we got on the list that we'll put in the next version, one was to require the extended optional parameter draft. And this is just to avoid the risk of some really long host name blowing out the size of the open. And then the other feedback was to provide some guidance on what to do if you have two sessions to the same box, or if you happen to have two different guys that use the same host name. So again, this is just implementation specific, but we'll put in some, some guidelines. Yep.
Job Snyder's, NTT. I recall from the mailing list that there was also some feedback that this might not be the best idea.
That's putting it mildly. Yes. So yes, there was a lot of activity on the mailing list that weekend. A lot of people, some people liked it, some people didn't. I don't know that we'll get consensus and convince everyone that they like it, but our customers like it and want it.
Ours don't care, and we use reverse DNS.
So the problem with using DNS is if you're doing IPv6 link local peering, you can't DNS that.
Yeah, so if you guys want to make comments, please actually come to the mic and do it. Thank you.
Lars Liemann from NetNode. I was a bit puzzled by that UTF-8 statement, because if these are host names, there's an RFC that specifies the specification of a host name, and there's no need for UTF-8. If you say 8-bit clean, that's fine, but once you go into the UTF-8 deep hole, there are lots of various mazes in there that you need to carefully consider. For instance, having two characters that look the same when printed, but actually differently encoded. So big rat nest.
Okay, so using UTF-8 was one of the points of feedback on the mailer. I believe it was from Jeff. So
be careful and check out carefully.
Hi, Jared Mach from NTT. So you shouldn't really be using link local for the BGP peering
Why is that?
Because there's a lot of reasons why. Starting with, you then have to go and do some sort of transmorg. If you're doing like IBGP or anything like that, you have to go and rewrite all your next hops for that. Just using that is not is an exercise in providing yourself a non-deterministic outcome. As opposed to using a globally routed IP address or some sort of ULA on the interface as opposed to doing this. Because all it takes is someone to patch a cable in on the wrong switch or the wrong location, and you not only lose connectivity with your stuff because you're not in the same layer 2 broadcast domain, but you have a whole bunch of other consequences that can happen when it comes to debugging and usability. When it comes to a network operator trying to actually interact with the device. So setting up reverse DNS isn't that hard. If you need help with it, I'm sure we can find a couple people who can help you, configure it in the zone file and make sure that you get the right thing there. It's really not that much of a barrier. It has to be used for a whole bunch of other network devices, especially any device that talks mail. I know that this device isn't talking SMTP necessarily, but a lot of these new routers that are all Linux-based and stuff like that, they may actually send out email or other telemetry as well and call back. And having the DNS stuff in there is really helpful when you have all of these additional things to have a human readable thing as opposed to FE80 : blah that you can't map back unless you go and you use the MAC address decoder ring. It's quite challenging to operate a device like that. I don't know how much experience you have in operating networks, but going and looking at all of this stuff, it's really important for us to be able to trace back stuff, especially when hunting down customer complaints.
So let me kind of clarify on the IPv6 link local peering. We do have many customers that use this in our implementation. The way they configure it, we don't force them to actually type out the link local address. We discover it via neighbor discovery. So they would configure neighbor gig0/1, and then we peer to the link local that we dynamically find on the other side. So if you switch a cable, it's not the end of the world.
So can I cut in line here for just a second and ask you to clarify whether in the deployments you're talking about the router is exposed to the public internet or not, or if it's sometimes one way and sometimes the other?
So most of these are going to be within in data center. So that's the primary use case.
Yeah. So I'll follow up on that. Is the data center connected to the internet?
Yes, at some point, I'm sure.
Okay.
That doesn't mean they're doing link local peering at that point.
Are you sure?
If you want to help your customers there very quickly, I would suggest just add a comment to your BGP summary and tell them what UTA ID is on the other side.
I'm sorry, add what to the show BGP summary? I didn't catch what you said.
Well,
add a column.
Add a column to show BGP summary or whatever your equivalent is, and instead of varying what you are putting out in the identification column, just add another one and give them currently available UTA ID. It's there. If your customer actually is duplicating those, he is probably the big problem. But the identification should be very clear.
Jeff Haas, I'm the one that said the UTF-8, and unfortunately the reason why I'm suggesting this is specifically because if you go to any of the ops guys who are going to be the ones reviewing the stuff at the ISG, that's what the ISG operations guys say we do these days. We don't put in just ASCII because we can't do, just servicing American customers. We can't do languages that are restricted to stuff that can be represented in Roman characters. So it is the right thing to do. To the second half of the comment, we probably don't want to use DNS-style puny code, although it's an interesting idea because you sort of devolve down to the existing DNS libraries for expanding that stuff. But all puny code is going to do is going to expand into a UTF-8 string anyway. So you're just moving the problem around slightly if you do that.
Any further questions, comments, or flames? Okay, thanks, Daniel.
Luann, just for your information, we have a good amount of time. You don't have to hustle through yours.
Wow. For once. Okay. Hi, I'm Luyan Fang, working in Microsoft Azure Networking in the SDN team. So, move on. So this draft, we started with pretty simple, saying that we want to have partition. The motivation of doing partition of the network is really for scaling. When you have tens of millions of endpoints to consider, one flat network, you have a scaling issues. So we want to do partition. Here we're not going to say more about how you partition, and it's more when you have a different partition, right? Either it's in the data center environment or it's in any other environment. What do we want to do with the BGP-LU? So here's the concern. And for this version, change different from 0.0. One is broaden the applicability of the proposal. So initially we were talking to support HSDN. Now it's saying for any network you want to partition and you want to use labels, you want to use BGP-LU to distribute labels, you could use such scheme. So it's more broader, applicability. Second point is we modify the procedure. So initially we have the coverage of using IGP. Now we say, okay, if you use BGP only, that we have a procedure for it too. The third point, probably the most important, we are introducing a new extended community. That is to identify the partition. Basically, enable the border nodes to, when you have partition, you have borders, right? So the border nodes to ambiguously signal the remote BGP speaker saying, with that new BGP-LU procedures requesting partition unique label should be executed, and enable the border node and BGP speaking label mapping server. That's a server managing the label mapping. It's more like a directory thing, right? To scope the label request and the response to a unique partition. So basically, maybe I should put up front so easier for folks to grasp this. Think about in the overlay world, we use L3 VPN. Basically, you partition the overlay space. So each VPN has its own RD, RT. You can use that to identify your particular VPN. You can use the same address in that different VPNs, but you have identifier. That's how you isolate your particular partition in the overlay layer 3 VPN, for example. And this is in the similar principle. We're doing it for the underlay. So in the underlay, you can cut into different partition, different domains, and you can do the same thing with the new extended community to identify that partition. So that's about it. Next page. Here is a topology. This is just abstract example. Like we were saying, it can be in data center environment. We started looking the very, very large scale in the data center environment, but it can be not in the data center environment, so there's no restriction. And also it's kind of just an abstract model. You may have the R1, R2 inside the partition. So this shadow, BN1, that's a border node. I should put a node there. BN1, BN2, they're border node. And BN3, BN4, they're border node. In this one, that shows a two hierarchy. So think about this. You can have one partition, maybe a core, and then you can have the next level of partition. Many of them may be data center, maybe some other network. And then under each one, if you really want to have cut the partition small so you can manage that, you can really TE that and so on. So you cut another level of partition. In this example, we use a 2 level. So you got a B1, BN1, BN2 as a border, BN3, BN4 as a border. And the Tor there are not the border. So the border and the non-border has different functions. They all connected with the BGP sessions to the LMS, that is Label Mapping Server. This is it's a label mapping server, and we may explain later, but I would like to mention that this label mapping server does not function as normal BGP route reflector. Initially, we're trying to use the BGP route reflector to modify the procedure, saying you do this type of a function. When you see the routes announced to you, and then you sign the label, you don't do as a typical BGP procedure saying, I will calculate the path, I will make the decisions. You don't. This one what we intend is to have the operator already put the design inside there. So the border, why do we have the border group, the BG? The border group is used when you're doing, say, ECMP. You're targeting to a group of nodes. So any of them can do the forwarding, the normal ECMP. So you make them into a group. You can use one label to indicate you're going into a group. If you want to do TE type of thing, you want to select a specific path, then you don't target that to the group. You use individual label. Underlay partition, I already explained. Next page. So this one is to show the typical BGP-LU process. You get NLRI and you have the CL3. So I have a little explanation on this CL3 and CL4. They will be now labeled PHP if the same LFIP is used for both UP1 and UP2. UP means underlay partition. Otherwise, otherwise locally allocated context label will be used. And BN3 and BN4 append the BGP community, value is BG2. This is not the new extended community, just BGP community. BG2 means I'm in the border group 2 when they advertise themselves in the UP1. So the green is the advertisement from BN4 and the blue is from BN3. Okay, next page. In this page, so we show from the view of it's the border node of UP1 learn routes to BN3 and BN4. Learn the routes. So basically, the top part, the 4 routes are 2 blue, 2 green. It's from that's from a BN1's view. BN1 on the left saying that it learns BN3 and BN4. BN3 is the blue, BN4 is the green. They each have 2 ways to go. That's why they each have 2 routes. So the little note on the L113, the contact, what does it mean? We're basically saying that you're in the partition 1 and you go through R1 and it's from BN3. So those are the small details. And the same thing as for the BN2 view, how the BN3, BN4 announced to BN2. Interior routes in the UP1, R1, R2 in the middle here, they're not the border node. So they do not modify or remove the border group community. They're just passing it. When BN1 and BN2 receive the LBGP routes for BN3 and BN4, they can conclude, okay, BN3 and BN4 belong to BG2 group. Next page. That is between the peers, right? The border from this end announcing to the border nodes on the other end. So now, all these nodes, we're talking about BN1, 2, 3, 4, they all advertise themselves to the LMS1. LMS1 is the label mapping server 1, because this is the UP1, and the next one is UP2, right? So we just take one domain to look at it. So they announce themselves over 1, 2, 3, 4. So it's pretty intuitive there. So here is the point we already mentioned. LMS may not run. If you wanted to run other functions, that's okay. But in this case, what we're doing is saying it doesn't require, but in this particular case, it doesn't, right? Run regular BGP decision process to compute the routes. So that's what we're doing with the LMS1. And LMS1 learns the group membership of BN3 and BN4 from the LBGP advertisement. Next page. So far what we've been talking is BGP-LU procedure. You can just do that with today's BGP-LU. What is new here? So basically we mentioned what's new. We're introducing new extended community. Why do we want the extended community? Initially we looked at the first version, 00 draft. We didn't use extended community. We say we'll just modify the route reflector procedures to perform such a function. You don't acting as typical, route decision maker and all these things. You just say, hey, I hold all these mapping table. I can tell you what to do. I learn routes from you. I tell you what label to use, and so on. This is like designed by the operator. So what here is saying that now we looked by doing that, it may not be such a clean way because your route reflectors and doing other things. How does it know when to do it in such a way, when not to do it in such a way? It's not the regular behavior. And to deal with the individual partitions, you don't have a very clean way. You can do it. You can definitely do it. It's doable, but it's more complicated than just give it a new extended community. So in that community, you want to do partition. This is a way to identify the partition. Very, I like to use analogy with the layer 3 VPN. That's how you use the RDRT to identify your VPN. So that's your partition in the overlay network. And this is your partition in the underlay network. So you use this extended community basically to identify the partition. So BN1, remember the picture, right? BN1 and BN2 are configured to be partition border nodes for the UP1. So the partition represented in the BGP extended community value. That's one. And two, when BN1 and the BN2 learn a destination that in that last picture was BN3, BN4 through the LBGP from a BGP peers through R1 and R2, right? Remember, they're in the middle. They don't change anything. And that belongs to UP1 partition. Then BN1 and BN2 do not allocate a label from a platform label space. What do? Instead, they learn the label for the destination. The destination in this example is BN3, BN4 in the partition label space from the label mapping server. So we basically using the label partition server as the mechanism we can put the operator design in it. Okay. But we still want to use BGP for label signaling distribution. The reason is if you consider the pure SDN environment, whatever, the way you don't use you can do in a way like you have a controller and then you have every box, you have an agent. You can do that. But does every box support an agent? Today we're talking about brownfield, or maybe for a long time we're in such a brownfield, a hybrid environment. You cannot really practically doing it. But every box, almost every box in the field, we know, they can do BGP. So we can use BGP to help us distribute the label. But here the BGP use is not the traditional way of using. Next page. So here is to show the routes. Now we added this extended community. Extended community, see from BN1 to LMS1 to the label mapping server, saying, hey, this is from, the routes to BN3 and the BN4. So notice that the green and the blue both added the extended community. R is saying, I'm requesting. And that's a UP1 content. So it identifies which partition you're in. And the next one is saying from the LMS to the BN1. In reality, you can see 4, but in reality, there are 3 labels. One is unique for the BN3. One is unique for BN4. The last 2, one is to give to BN3, one is to give to BN4, but they are not unique. Because they're in a group. And the G we defined as group. So we use a group to, that's a group. So that's a same label. And BLG2 is the partition label assigned for border node group BG2. So just explain what we mean by all these symbols. Next page. So BN2, I think we can skip those. Basically, this is talking about the same process we talked for BN1. Now we talk for BN2. Same thing, right? The BN2 will send a request, hey, I need label for these. I already know certain things, but I need you to assign the particular label for me. And then the LMS will send, here are the labels. So including the individual label, including the group label. Next page. And all the BNs, the border nodes in the UP2, advertise themselves. I think the last part we're talking about, okay, this one is, the reason we put this one here is because there is, we have this node we call, let's say they're Tor, right? They are not part of the border nodes. So we want to show they will have little difference in the advertisement. The border nodes will identify the border group, which border group they belong to. And these guys don't belong to any border group, therefore they don't carry that community. Next page. And BNs of UP2 learn routes to Tor 1 and Tor 2. So these are the routes passing the green and the blue. I think we're kind of okay now. Move on. Yeah, I believe we're talking similar things now. So maybe I should talk a little more the last page. Yeah. Back up. Go back? That's fine. Yeah, back. Okay. Yeah. So from the view of a BN3, you will have an NRI with the Tor 1, and they don't have a community. They don't have a border group there. So same as Tor 2. So Tor 1, Tor 2, going through this way, going through that way. And Tor 1 and Tor 2 do not belong to any border group, we already said in this example. Therefore, it's just a simple format. I don't think I need to say the last part. It's the same. It's a BN3 view and BN4 view. Okay, next page. So now BN3 learns partition label for the Tor 1 and Tor 2, and from a BN3 to the LMS2. So now we're talking about this partition. They include the Tors, right? These are the requests. So I need label for it, and then that's a response back from the LMS2 to BN3, saying here are the labels. Okay, Next one. So here's our summary. So basically, the reason for partition, partition is a key aspect for scaling. BGP is considered here as a tool. It's a natural glue to connect the partitions, and it's widely used. And next, we use it heavily. So the new extended community allow us to support the underlay partition in an efficient and a clean way, because we tried multiple different ways, and maybe we should do this rather clean than mess up so many other things to be complicated. This will be very simple. If you know at layer 3 VPN, well, this is the same principle. It will be similar to the layer 3 VPN and supports brownfield deployment well. And BGP is used as a protocol to request and learn the operator assign the labels here. It's not to decide on the computer route. The procedure defined here can be used for any partition technology. So it's not exactly as the intent at the beginning, right? We say, we have a design on the HSDN. So now it's beyond its title, right? It's any partition you want to use such a thing, you can use. The next step, we really like to get feedbacks from the folks in the working group, and we like to, very much welcome contributions and to work together on the draft. Once we have, new update to make it more, to get the feedback to complete and to modify and so on, then we'll ask for working group adoption. Thank you.
Questions, comments, flames, compliments?
Wow.
Going once? No?
Hi, Lucy.
Hi, Lucy Yang from Huawei. One clarification, is this label allocation also for just for unicast package, or multicast do you have another allocation for the multicast label?
At this point, we're consider just building the pipelines.
Right.
If multicast is something bring additional, we actually look quite about multicast thing as well, but we'll come to discuss.
Anything else? Two things then. One is, I see, oh no, actually I see two blue sheets, so never mind. The other one is to remind you that we have a second meeting on Friday. Anything else, Sue?
Just that the second meeting's time is 11:50 to 13:20. We are the last slot on Friday. So please, we hope to see many of you here.
Thanks, everyone. We are concluded for today.
Thank you.